let's continue looking at some trig equations. This video is going to focus on trig equations where we have cosine, sine, tangent of something other than just x. So like 3x, 2x, x minus or x plus something, and we're just going to see how that affects our solutions. Okay, so let's dive in. This video is going to have a lot of examples, so if you need to bounce around, feel free to. First example that we're going to do is cosine of 3x is equal to 1. Okay, so good news, we're already isolated, but again, I'm looking at places on the unit circle where the value of cosine is 1. Okay, and so I'm just going to treat this, if you need to think of this as just like an angle theta, you sure can. So you can say like cosine of theta is equal to 1. And then you can say, okay, well, on the unit circle, that is going to occur when theta is equal to 0 to pi for sure. So then what we have to do is say, well, we're not actually working with theta, right? We're working with 3x. So let's say 3x is equal to 0 plus 2 pi k, right? Just to capture all the cases. So we know the first instance of this cosine being 1 occurs at 0 radians, and then every 2 pi radians thereafter. So that's why we tack on the plus 2 pi k. And then, so my angle is 3x, right? So then we have to solve for x, divide by 3. Okay, so x is equal to, and well, 0 divided by 3 is still 0, so let's just get rid of it. So we have 2 pi k over 3. And personally, I like to write this as 2 pi over 3 times k, because then I can just take, k is a number, so it's, negative 1, or negative 1, 0, 1, 2, 3, and so on and so forth in both directions. So k is just an integer. Okay, and so it says, I think I'm pretty much done. I just have to say find all the solutions in the interval. Haven't done that, but my answer here, B, is what I found. So this is all possible solutions. Okay. For A, now I need to think, okay, well, 2 pi over 3, and then k is a number. K is a number, 0, 1, 2, 3. So certainly there's 0, right, if k was 0. And then if k was 1, so I'm actually just testing values. So 0 and then 2 pi over 3 would be if k was 1. If k is 2, I'd get 4 pi over 3. And then if I get 2, or sorry, if I get 3, then it would be 6 pi over 3, which is 2 pi. But that's the end of my, that's not included in my boundary, so I'm actually just going to get rid of that. Okay, so those are my 3 answers for part A. Okay, so again, to find the specific solutions, just start substituting in values of k. Typically 0, 1, 2, 3, whatever, are good things to try. And just keep plugging them in until you get something that's outside of your range, or outside of your domain, rather. Okay, next one, let's solve for theta, right? So need to isolate the trig function first. So, okay, sine of 2 theta. I move the square root of 3 over to the other side, and then I would divide the 2 over, kind of just doing 2 steps at once. And then, okay, now I'm thinking, okay, sine of my angle, right, is equal to square root of 3 over 2. So now I have to go to my unit circle, and I ask myself, what angles exist where sine, which is the y value, is square root of 3 over 2. Okay, so feel free to pull up your unit circle if you need to. But it turns out that the angles of interest are, so the angle that I have, 2 pi, or 2 theta, sorry. So sine is square root of 3 over 2 at positive pi over 3, and also at 2 pi over 3. And then remember, for each of these, I need to tack on the period, so plus 2 pi k. And then isolate theta in both cases, so divide both sides by 2. Okay, so this would be pi over 6. Okay, dividing by 2 is the same as multiplying by 1/2. And then I have to do it to both terms, so plus pi k. And then this would be theta is equal to pi over 3 plus pi k. Okay, so these are my answers to part B. And so that's always nice to find. I don't know why, but the problems, we used to use a textbook, and so these come from the textbook, but they always put the general solution set after the specific one, and I always think it's easier to do it the other way. I digress. But so if I'm trying to find the specific specific angles within the unit circle that satisfy this, from each of these, so I'd get, pi over 6, and then over here I'd get, pi over 3. But I have to remember I'm adding pi k on there, right? So if k is 0 in both instances, I would just get the pi over 6 and the pi over 3. Okay, then I have to increase k. If k is 1, over here I get 7 pi over 6. Over here, I would get 4 pi over 3. Okay, and then I say, okay, well, just gonna try it again. If I let k be 2, right, to 2 pi, I get something, so I'd get like 13 pi over 6, which is outside of the domain, and then something like 7 pi over 6 over here too, and that's outside of our domain. So these are our only values, okay? So again, make sure that you're trying values for k to find all possible solutions. All right, the last two. I want you to pause the video, try these out on your own, and resume the video when you want to see the solution. And here are the answers. Okay, first thing, move the 1 over, right, and then tangent of alpha over 2 is equal to 1 precisely when, so tangent is 1 at the angle pi over 4. So I just set the angle alpha over 2 in this case equal to pi over 4 plus pi k. You would actually also find that it's equal to, tangent is equal to 1 at 5 pi over 4, but the pi over k, or the pi k that you're adding on includes it. So you could do it, but it's redundant. So here we go. Isolate alpha, multiply by 2 to every single term, right? You have to remember, include the multiplication to 2 to the 2 pi, or the pi k. And then you get your answer for all possible angles. And then within the unit circle, just one rotation of it, the only angle that would be satisfied is pi over 2, okay? Because according to this, you would add on 2 pi k, and that's already one more revolution, okay? The next one looks surprisingly difficult, but it actually isn't too bad. So I just kind of moved the square root of 3 over 2 over to the right side of the equation. And then for me, I had to say, okay, well, this junk in here, the beta minus pi over 6, that is just an angle. So if it helps you to make that substitution, just say it's an angle, you sure can. But then I went to my unit circle and I asked myself again, where on the unit circle is sine, the y value, negative square root of 3 over 2? Oh, 2 places, 4 pi over 3 and 5 pi over 3. Okay, so I have to set my angle, which was, it was theta, but it's actually beta minus 6, or pi over 6 rather, equal to both of those, and then tacking on the period. Okay, if we do that, then add pi over 6 to both sides, and when you do it, you're just adding like terms, so the k isn't like terms with the 4 pi over 3, so you're just adding it to that term. But anyway, you reduce, you get 3 pi over 2 and 11 pi over 6 for the other one, plus 2 pi k, and then that would be your all possible solutions. And then for your specific solutions within the unit circle, it's just 3 pi over 2 and 11 pi over 6. All right, so now we have some more trig equations under our belt, and there might be a few more that we might be able to work through.